quick raise of hands. How many of you know what AWS is? Okay, great. So I'm not going to talk about AWS here. So I'm not going to talk about what AWS is, what we do. We have a stall outside. I'm going to be outside after the talk, so please feel free to come by and talk to me. More than happy to help with those questions. So quickly, what is big data? So when I asked this to one of my friends, right, he gave me this definition. When you do a directory listing on a folder and the light starts to flicker, that is big data. The data is huge, right? The data is really, really huge. But how do I, are you able to hear me guys at the last? Okay, perfect. I don't need this, thanks. So the data is really, really huge and we need a proper definition for it. So we have people come and talk about the 5 V's. So I'm only going to talk about the 3 V's here. I am saying data is big when I need to think out of the box. I need to innovate to collect, store, organize, analyze and share the data. So this is what I call as big data. So big data has velocity, volume and variety. Because of these characteristics, it becomes really difficult for you to collect the data, store it, organize and analyze the data. And you need to think out of the box to do it. This doesn't happen in databases. This doesn't happen on small boxes that you give. So quickly going there. So we have generation of big data. We have collection and storage. We have analytics and computation and collaboration and sharing. The easiest thing now is data generation. Data generation is falling. Every person who's having a smartphone here is generating data. As we sit here, as we talk, people are generating data. How many of you have actually gone to maps.google.co.in/location-history? Have everybody gone there? Go to that site. Go to the site. Go to the site and see. Hello. Okay. So, okay, I'm going to be more loud now. Okay, great. So how many of you have gone to that site to see what is happening there? How many of you have gone to that site to see how much data your Android phone is actually sending back to your servers? The Google servers are collecting every piece of information on where you are located, what you are doing. So generation of data is falling and falling really, really fast. So this is what we are anticipating, how unconstrained the data growth is going to become. We are now collecting data in GBs and TBs. We have already reached the PB range, and by 2020 we should be reaching the zettabyte range. This is the amount of data that we are collecting. We are able to collect it very easily, but unfortunately we are not able to store it and analyze it. That's where our challenges start. Where do we collect these data from? It collects from Android phones, as I mentioned now. We also collect it from websites, clickstream analysis. Whenever you go to flipkart.com, you go to jabong.com or go to zovi.com, they are collecting data of what products you are clicking, what products you are seeing, what products you are ignoring to see. So that how can they make it better for you? How can they do recommendations for you? So Professor gave a very good example on machine learning, right? So machine learning is what these people do. So they try to figure out how the analysis is working. Clickstream analysis. Sensor data. Your weather data is being collected. How many of you saw the 2012 movie? Doomsday Conference. So we collect weather data to predict what is going to happen to the weather. El Nino effect. We are predicting weather. So weather data is being collected. Social media, we already know that, right? We are doing 450 million plus tweets a day. 450 million tweets a day. And there is no way to do a fire hose processing on Twitter today. There is so much data there that social analytics is becoming a challenge. So, the volume of data is ever increasing, and I've got a lower cost and higher throughput for generation. I've got a high throughput for generation. Each one of you is, in this room, if I have 100 people are using Android phones. Collectively, you are sending at least 100 MB a minute back into Google. What is getting constrained? My collection and storage, analytics and computation, and collaboration and sharing. what is the use of me generating this much data, taking this data in, if I'm not able to collect the data and store it? I'm generating the data, but if I cannot store it and do analytics and further share my analytics, what is the use of doing this data? So, this is what we predict that your data growth is going to be. And what do we have for analysis? The blue line is what we have for analysis. We are having so little data for analysis because we don't have means of storing this data. I'm generating petabytes of data, but I can only give terabytes of data for analysis. I don't have ways to store this data. So, what is going to help you do this? Cloud computing. So cloud computing is nothing but utility computing, which gives you elastic and highly scalable compute and storage. No capital expenses. So you don't have to go and predict, okay, I need 15 petabytes of storage. Tomorrow I'll need 20 petabytes of storage. Day after tomorrow it will be 20 zettabytes of storage. I'll go and fill this room with disks, anticipating the storage. No capital expense. So I don't have to anticipate storage. I'll keep putting data into it and it keeps storing data. Pay per use. Use it when you need it. You don't know how your data is going to grow, right? Today, there may be 100 users on your site. You need clickstream analysis for 100 users. But tomorrow, you may have like 1 million users on your site. And when you do clickstream analysis for 1 million users, you need so much power. And that 1 million users may come back to 10,000 users later, at a later point in time. And pay per use helps them. So when you have 1 million users, you pay for a higher bandwidth, you pay for a higher processing power, but when you have 1,000 users, you bring it back down in size. Available on demand. Whenever you need it, ask for it, you get it. So all these allow you to remove those constraints we spoke about. So we can accelerate collection and storage, we can accelerate analytics and computation, we can accelerate collaboration and sharing by using cloud computing. So let us talk about Razorfish. How many of you know what Razorfish is? So Razorfish is a media company, so they do ad rolls, pre-ad rolls, post-ad rolls, they do analytics on looking at what people are doing so that I can target ads for them, retargeting of ads for them, right? So, there are 3.5 billion records, 71 million unique cookies, 1.7 million targeted ads per day. That's what they were trying to do. And what are they trying to do? They were saying users recently purchased a sports movie, so can I go and sell Madden to them? NFL game. Have you anybody played NFL here? Madden? No. Okay. So can I go and sell that game to a person who went and bought a sports show? So the person goes to Amazon.com, buys a sports show. Next time he goes to some other website, I'm able to show him an ad of Madden and give him a 30% discount. That's what they were trying to do. And this data was super high for them. 3.5 billion records were coming in. Clickstream analysis was happening. This is big data. The velocity is there. The variety of data is there. It is coming from Clickstream. It is coming from tweets. Correct? The variety is there. And we have the volume as well for this data. And with this variety and volume, they process this using AWS, using a service called Elastic MapReduce, which we're going to talk about. And they were able to get 500% return on ad spend. And they went from 2 months procurement time to a minute on this. They were able to procure hardware in minutes and do this processing instead of waiting 2 months to do the processing. How did they do that? They used big data technology. So big data technology is nothing but techniques that allow you to productively work on the data at any scale. Not at a fixed scale, at any scale. The data comes in petabytes, zettabytes, gigabytes. I can use my techniques to work with that data. Now, how does AWS help in the various stages of big data? So for accelerating my data, I have AWS data pipeline that allows me to do workflows on data. I've got generation that is already happening. I don't have to help you for generation. You go and write your programs to generate the data. For collection and storage, I've got Amazon S3. I've got storage gateways, DynamoDB, which is a NoSQL database, Redshift, which is a Redshift, which is a petabyte scale data warehouse, relational database service where we give you both Oracle, MySQL, Postgres, and SQL Server on a pay-as-you-go model. Kinesis is our way to collect data on a real-time basis. Kinesis is used to collect data from you on a real-time basis. Analytics and computation, I have got EC2 to do my computation jobs. I've got Elastic MapReduce. Collaboration and sharing, I can again use S3 to collaborate and share as well. So let us get into the details of this, right? Amazon Simple Storage Service. Storage has classically been your biggest challenge for anybody who ever does data collection and want to store the data. You always go and ask your IT department, hey, can I get another 50 GB of hard disk? Can I get another 50 terabytes of hard disk into my SAN storage? And that's a challenge. It has always been a challenge. With S3, you get unlimited storage. Unlimited storage that grows as your business grows. You never have to allocate storage. You keep dropping data into it and we keep storing data into it. And we give you 11 nines of durability on S3, which basically means you store an object for 100,000 years, you may lose that object. If you store it for 100,000 years, you may lose that object. That's what we give it as durability for you. So, what is Elastic MapReduce? So, these two are the main functions of my big data technology. So, what is Elastic MapReduce? Elastic MapReduce is Hadoop in the cloud. Sorry, I'm asking this question, but how many of you are actively using Hadoop today? Okay. So, what is the biggest challenge in Hadoop for you guys? Configuration, exactly. Correct? So what is Hadoop? Let us look at what Hadoop is first. Hadoop is an open source framework for parallel processing huge amounts of data on a cluster of machines. On commodity hardware, how do I process data? Okay, huge amount of data. That's what Hadoop is all about. So classically Hadoop, the problem with Hadoop is how do I bring up this whole cluster? How do I add nodes to the cluster? How do I remove nodes from the cluster? How do I make the cluster available, or how do I make the cluster not available? When I don't want it, why do I want to keep running that cluster? I'm not doing any processing during the day hours. Should I run the cluster still? That's what a lot of people have questions on. So how does EMR help you today? So, how does it work? The whole piece, putting together all the pieces. I have got data, I put it into S3. I launch my cluster, pick up the Hadoop distribution. I say how many nodes I need. I'll say what is a node type, whether I need a node with high CPU, high memory, high storage, completely left to you. You choose the node type and then choose the Hadoop apps that you want. Hive, Pig, HBase, Ganglia, Scoop, Uzi, whatever you want. Choose those and run the cluster and get the results. When the cluster is running, I can resize the cluster, add more nodes to it, remove nodes from it as well. I can use something called spot instances that give me the ability to go and bid for a node. I don't have to have this node, I don't want to pay the node price at the market price. I want to bid at a lower value. Bid for it, get it at a lower price, anywhere between 80 to 90% discount from the on-demand price and run your job. Correct? And launch parallel clusters. I need to look at the data, but that data has to be looked at multiple people. My CEO wants a different view of the same data, whereas my clickstream guys need a different view of the data. My finance guys need a different view of the data. Take the same data and push it into multiple clusters to process it at the same time. And terminate the cluster when you don't need it. Pay as you go, on demand. Bring it up, use it, terminate it. So this is exactly what Netflix is doing today. So Netflix is basically taking the data, putting it into S3, all their clickstream data, all their video data, they're putting it into S3, and then saying, okay, I'll do a processing using EMR clusters. I will bring up EMR clusters as needed, do a processing for 3 hours, 4 hours a day, and then shut down the cluster when not needed. So, what does it cost for me to run a 100 node Elastic MapReduce cluster? it costs me 450 rupees an hour. So the professor was saying I need, it takes 1,000 hours to do a particular ML sequence. If I give you, with one mission it takes 1,000 hours. If I give you 1,000 missions, how long is it going to take? 1 hour. And for us, it doesn't matter whether you run a mission for 1,000 hours or you run 1,000 missions for 1 hour, it's going to cost you the same thing. And we have capacity to give you. So 450 rupees an hour, what can I equate it to? I can equate it to thali, right? So I'm just preluding for the lunch here, that's about it, okay? So I can put it for the thali, and that is 450 rupees for you. And you can run your Elastic MapReduce 100 node cluster for that cost. Now, people say, okay, I'm running 100 node cluster, you're saying 1,000 node clusters, 10,000 node clusters. Do you have capacity to give me? Yes. AWS adds capacity into its data centers every day to support a global 7 billion enterprise. Whatever servers, racks, switches, networking equipment that is needed for a 7 billion global enterprise to run is being added every day into our data centers across the world. So we have 10 regions across the world. You can use any of the 10 regions to launch your cluster. You can use any of the 10 regions to store your data closer to the user. The user gets better proximity to send the data. Once the data is stored there, take the data and process it, and then centralize the data if you want to do more analysis or processing on it. EMR clusters can be launched anywhere in the world in the 10 regions that we are having. 3 in the US, 1 in Sao Paulo, Brazil, 1 in Europe, 3 in Asia Pac, and 1 in China. I'm not including China into Asia Pac, but 1 in China separately. So, we have thousands of customers who have launched 5 million plus clusters in the last 3 years since we launched EMR as a service. A lot of these names you must be aware of. Amazon.com uses us. Razorfish, New York Times, Netflix, lot of customers use us. Lot of them use us. Okay? We have a lot of customers in India using us. A lot of them are not referenceable. We have people using us on the ad serving technology, people using us in the RTB world, people using us in sentiment analysis, okay? Machine learning. They all use EMR. So, EMR is, or Hadoop is not only Hadoop, right? It's not only the elephant. There is a whole load of animals in the zoo. And these animals all work together to give you a better data analysis work. So, I've got Hive, I've got Pig, I've got Mahout, I've got HBase, I've got Spark, I've got Shark, I've got a whole load of stuff. So let us look at each of these and see what they are responsible for in the Hadoop world and how you can use it. So EMR works with all these zoo animals. So Hive, data warehouse for Hadoop. I can run my SQL queries on Hive, ANSI compliant SQL queries. Initially developed at Facebook. Facebook has moved on from that. They have gone into a different data warehouse today, and we support that as well. For your information, we support that as well. So you can actually use that Facebook data warehouse to run on EMR. We support Pig. Sorry, how many of you know these animals? Not the animals, but the languages behind them. Okay, good. So Pig is a high-level programming language. So I can do UDFs on Pig, user-defined functions on Pig, run them on EMR. We support HBase. We give you a HBase that can be actually snapshotted and kept in S3 and bought in whenever needed. So managed HBase is available. We support Mahout for machine learning. It works amazingly well. We support Spark, in-memory MapReduce. So if you are doing MapReduce, then and you want real high speeds for it, Spark is what you should look at. And Shark is something that works with Spark to give you a HiveQL, in-memory HiveQL, in-memory data warehouse. Then we work with Ganglia. So Ganglia is your monitoring server, monitoring subsystem. You can bootload your EMR with ganglia. We work with R. How many of you use R here? So R is really popular, right? R is something that statisticians like. They love to work on R, and we work with R as well. So R is pre-built onto EMR. You don't even have to bootstrap the whole cluster with R. R comes along with EMR. You can start using it from day one. So we also support MapR technologies. Anybody using MapR here today? Nobody. MapR, okay. MapR is an enterprise grade Hadoop, I could say, release which supports NFS. It doesn't need name nodes. Name nodes are single point of failures in a Hadoop ecosystem. We give you job tracker, high availability, cluster mirroring, and things like that. And that is available today on EMR as well. So EMR integrates with the Hadoop ecosystem in general. So we work with Pentaho, MicroStrategy, Talon, Jaspersoft, Informatica to deliver a combined solution to you. So if you're already using Informatica, you can connect it back into EMR. If you're using MicroStrategy for reporting, MicroStrategy can work with EMR as well. So what can I do with EMR? I know I can collect and analyze it. I have seen it, I'm collecting it, I'm analyzing it, I've done my analysis, I've collected it into S3, I've analyzed it on Amazon EMR. Then I now need to collaborate and share with it, right? That's the next step towards a better use of big data. Put your data into Amazon Redshift once you have done your work. Amazon Redshift is a petabyte scale data warehouse. No upfront cost, pay as you go, the data warehouse the Amazon way. Data warehouse is available today, all inclusive, software, hardware, backup. So we work with Actuate, a dear friend who spoke in the morning, we work with them. We work with Jaspersoft. Jaspersoft is available in our marketplace for $1 an hour. An enterprise grade BI system available at $1 an hour for unlimited number of users. Jaspersoft on the marketplace. Amazon Marketplace is like your app store for your iPad or Kindle or Android. You go and say, hey, I want this software. You pick up the software, use it on a pay-as-you-go model, stop it. We don't charge you for it. Works greatly. So, big data is great, but what about my data that I'm generating on-premise? Enterprises generate so much data on-premise. What do I do with all those data? On-premise data can also be moved to Redshift, and then you can plug it into your reporting or BI tool. Okay, I added these slides when I was sitting there. I wanted to show this. There was a lot of questions on SAP HANA, and I wanted to talk about it a bit. So SAP HANA works amazingly well on AWS. SAP HANA with SAP BW, which is the business warehouse of SAP, they recently did a study where they were able to run a 111 node SAP HANA instance and get amazing performance. SAP HANA works very well with MapReduce, EMR. So from EMR, you can push the data into SAP HANA for processing. We have real-time event processing using Kinesis. Take the data into Kinesis, and from Kinesis, you can move it to SAP HANA as well. The other pieces are always there. You got SAP IQ, OP RDBMS, and other sources from where you can move it to SAP HANA, and finally connect it to business applications so that you can work on it. So, what did SAP do on us? They ran a 111 node cluster of SAP HANA to process 3 million queries per hour. There were 3 million queries processed per hour. On what size of data? 60 billion rows were processed. So they were able to basically run 3 million queries an hour in that data warehouse, SAP HANA warehouse. So what was the configuration? We were running at 16 cores, 60 GB of RAM, and 600 million rows per instance, which equates to 1,776 cores, 6.6 terabytes of RAM, and 60 billion rows. They did the study. It's available on their blog. If you're interested in it, come out, talk to me. I'm happy to share the blog details with you. And what did it cost them to run? $400 an hour. That's what it costed them to run this cluster. 100 node SAP HANA cluster costed them $400 an hour, which is effectively getting a Rolls-Royce performance for the cost of a Ford. SAP HANA is available in our marketplace via SAP for $1 an hour. It's available at our marketplace for $1 an hour. So you start the HANA warehouse, you do your processing, shut it down, we stop charging you for it. SAP stops charging you for it. $1 an hour, 99 cents an hour to be approximate. You run your instance, do all your processing, do your analytics for 8 hours a day, shut it down, you only pay $8 a day for SAP HANA. Available as an appliance on marketplace. So, I want to leave you with a few thoughts. Experiment often, fail quickly at low cost, and that gives you more innovation. You have to fail quickly at a low cost. Remember that. Whether it is an enterprise, whether it is a startup, I don't want to, my cost of failure should not be very high. My cost of failure should be really, really low. I go to my manager and say, hey, I have this great innovative idea I want to implement, and I need a 10-node cluster to do this. The next question he's going to ask is, what happens if your idea goes south and nobody likes your idea? Who's going to use the 10-node cluster? So I need to find a person who is going to use the cluster, or I need to find a bakra before I start innovating on my product. Correct? With AWS, that's not the case. Think, start a 10-node, start a 100-node cluster, try it out and experiment. If it doesn't work, shut it down, walk away. We stop charging you. The minute you shut it down, we stop charging you. Data is the new oil. Your data is super important for you in this business. Very, very important for you in this business. It doesn't come cheap, but it is very important. You need to understand that. And data is going to deliver value to you in tons. Data is the new oil for you. I have one last question. How does Rajinikanth do big data? So it's a Rajinikanth joke. Sorry. How does Rajinikanth do big data? In his hands. Okay? Exactly. There we go. So thank you guys. Thanks.